So hi, everyone. This is an amazing room. And I mean, it should be a concert here or something and not a session on Visual Studio 2015. But that's what you get. So I hope you're enjoying DevWeek. And I'm looking forward to seeing you here for the rest of the conference as well. I have some talks tomorrow and on Thursday. There's lots of new stuff in the Microsoft stack. And one of the major announcements this year is and will be Visual Studio 2015. Which is just barely out. It's not in release form yet. There have been multiple community previews. CTP 1, CTP 2, all the way up to CTP 6 are now available. But it's not out yet. So some of the features I'm going to be talking about might change before the whole thing is finally released. And also, if you see some demo glitches, then you know who to blame. I've done my best, but there are some things that are still not quite reliable. There are demos that occasionally work and occasionally don't. So with that said, let's hope for the best. My name is Sasha Goldshtein. I live in Israel. I work for an Israeli training and consulting company called Sela. And if you'd like to stay in touch, there's my blog and Twitter. If you have any questions, please feel free to approach and ask. I do a lot of things, including, of course, programming on the Microsoft stack. So this talk here is going to be about Visual Studio 2015. There are several perspectives from which you could approach this kind of talk. There are so many features that it's simply infeasible to cover everything in just an hour and a half, and also give you some demos, not just show you screenshots. So I'm not going to talk about every single new feature there is in Visual Studio 2015. For example, if you're doing front-end web development, then you might need another session, probably about the same length, just to cover all the new cool stuff there is for front-end web application development. But if you're doing .NET on the server side, if you're doing classic desktop applications, even if you're doing C++, there's something here for you in this talk. So just to put things into context, Visual Studio 2015 is part of the so-called .NET 2015 release wave. Now, there is really no such thing as .NET 2015. There isn't a version of the .NET framework called .NET 2015. But that's sort of the umbrella under which Microsoft have chosen to put this whole release wave. So under this release umbrella, we have Visual Studio 2015, which is, for the first time, powered by the new generation of C# and VB compilers, which is the Roslyn compiler platform. This is a huge undertaking on its own, but I'm not going to cover Roslyn in this talk. So we're going to focus on the Visual Studio IDE and all associated features like the debugger, the performance tools. We're not going to talk about the managed languages themselves. Now, I have a talk, I think tomorrow, about C# 6. Which will cover most of the innovation in the languages. There was, I think, today a talk about Roslyn by some other speaker, whose name I don't recall right now. And that covered the compiler platform side of things. So there really is more innovation around Visual Studio and the managed languages and compilers than what we're going to see here. Then we also have the runtime side of things, the runtime innovation, which I will cover briefly. And so there's stuff like a new just-in-time compiler, investments in vectorization for C# code, really cool stuff that has to do with performance and boosting really the kind of things you can do with .NET applications. And finally, there's also the open source .NET Core, which was announced in November. It's basically a subset of the .NET framework, which is in fact, already open sourced on GitHub, and some additional portions of the framework which will be released on GitHub in the future. So this is, again, a huge announcement in itself. And on Thursday, I think, I have a session covering .NET Core. So just to give you the context for today, it's mostly going to be Visual Studio itself, the IDE, performance tools, debugging tools, and the runtime innovation parts. So with that said, let's just briefly review a few features, and I'll show you demos of the ones I think are particularly interesting for both .NET and C++ developers. By the way, do I have any C++ developers in the audience? Not even one? OK, oh, great. Thank you. Yes, excellent. I also do C++ a lot, so it's always good to see some fellows. yeah, we're going to see one feature which is C++ specific. So it's pretty cool. But the rest of it is going to be C# and .NET mostly. So one thing I'd like to mention is the editor. And the code editor in Visual Studio 2015 now relies on the Roslyn compiler platform again. And so without going too deep into what exactly it means and what the Roslyn platform enables us to do, the editor and the related functionality like refactorings and live code analysis and those red squigglies you see when you mistype something in Visual Studio, all of these things were basically redesigned and re-implemented from scratch, which hopefully means they're working better. And there's also some ideas which Microsoft and Visual Studio kind of borrowed from other productivity tools, like, for example, this light bulb over there, which I assume some of you know where it was borrowed from. So anyway, there is lots of investment in the editor, in refactorings, adding new refactorings and new code fixes, as they're called. And most of this thing can happen live without requiring a compilation cycle. So you basically type some code, and Visual Studio, the IDE, the compiler, parse it on the fly and suggest code fixes and refactorings, which is more powerful than the way it used to be before. And it's also, in most cases, faster. One nice thing we get out of this whole new IDE reimplementation is a really nice preview support, inline preview for refactorings and code fixes. So you don't have to go through this model dialog which previews the changes the refactoring is going to make to your code. Instead, you can just see this kind of nice inline window which gives you an immediate preview. So for example, here, to remove unnecessary usings. There is also support in the same spirit for more code analysis features, including more opportunities for people implementing code analysis packs. And there aren't many of those yet, but some people in the open source community, some Microsoft MVPs, are working on a wave of open source analysis tools for C#, for Visual Studio. And one example of those efforts is the Azure Cloud Code Analysis Pack, which is basically this thing you install, you add to your Visual Studio, kind of like a NuGet package, and it will try to look out for patterns of using Azure features incorrectly. Specifically, right now, it's focused on a certain set of client libraries for Azure, such as storage and cloud services and websites. Not every Azure library out there, but it will look out for common issues as you type in your Azure-related code and offer you suggestions, quick fixes, refactorings, which can improve lots of things. They can be bugs that it will fix for you. Could be cost issues, like using an API, which might end up costing more money than an alternative, which these tools can offer. So it's going to be easier to author code analysis experiences in Visual Studio, again, based on the same Roslyn platform. And it was, in fact, possible before. It's not like it's the first time there's static code analysis and code fixes in Visual Studio, but it was extremely complicated. And I'm saying this as someone who wrote quite a few of those static analysis rules back in the day. It's an undocumented and pretty much your own process. So Roslyn changes all that and really opens up the field for more open source code analysis tools. By the way, I haven't mentioned it, but Roslyn itself, this new compiler platform, and the compilers for C# and VB are also going open source. They are, in fact, at this point, already open source. They used to be on Codeplex, and then Microsoft realized all the cool kids are on GitHub, so now they're all on GitHub as well. The migration was just completed a couple of weeks ago. So again, on the code editor side, there's a bunch of cool new features, which you're going to discover on your own, I think, as you play with Visual Studio 2015 when it is released. And by the way, like I've said, there are multiple previews available. I'm going to be working with CTP 5 and CTP 6 during this session, which are the latest previews. And once this thing is out, I really encourage you to give it a try. So let's talk a little bit more about the debugging side of things. This is one of my favorite areas in general. I like debugging, I like internals, I like performance investigations. And so one of the areas I chose to focus on deliberately is the debugging and diagnostics improvements in Visual Studio 2015. And there are multiple areas which I'd like to show you. One is the improved breakpoint experience. And I realize it's 4 p.m., and you're thinking, what could be more boring than setting up breakpoints? I guess. So yeah, there is a redesigned breakpoint configuration experience, which is in fact more useful than it sounds, because Visual Studio has lots of advanced breakpoint features like conditional breakpoints and trace points and breakpoints that will only stop after a certain number of hits, so a hit count conditional breakpoint. And all of these features are really not quite accessible as you configure a new breakpoint. So part of this new redesign is to improve the process of configuring advanced breakpoints, to make it more straightforward. Another thing, which is cool, but it's kind of half-baked at this point, I really hope it's going to work during the demo, is the Visual Tree Explorer for WPF applications. Is anyone here building a WPF client? Yeah, a few of you, OK. So for WPF applications, Visual Studio 2015 has this really nice Visual Tree Explorer where you can see the relationships between different views in your view hierarchy and inspect properties of those views, like take a button and inspect its title and color and background, and also change those properties at runtime. So as you are debugging your application, you can make changes without touching your code, just through a nice visual window. And another feature, which I'll show you in a demo right now, is the timeline tool for WPF applications, which really helps build responsive desktop applications, responsive in terms of the user interface, of course, and also understand where you're spending your CPU time in a desktop application. And this timeline tool, which I'll show you right now, is an extension of a tool called the XAML UI responsiveness tool, which Microsoft released ages ago, like in Visual Studio 2012 or something. But it was only for Metro applications, modern applications, Windows Store applications. Now it's also available for WPF, which makes it a lot more useful, I think. So before I jump into the demo, I just want to mention, almost everything I'm going to show you today is available in all the Visual Studio product editions. So professional, premium, ultimate, community, whatever you have, it's available there, with a few exceptions. And this is not an exception. This is all available in the professional edition and the community edition as well. So let me give you a quick look of what the timeline tool looks like. I have here this WPF application, which is really simple. And it has a responsiveness issue. It's called Stupid Notepad. And so the problem with it is that I start typing, and occasionally the GUI isn't responding to my keystrokes. And it's kind of annoying because it's random, and I can't really put my finger on it, but I'm just typing, and then occasionally it just stops updating the screen. And this is the kind of problem that traditional profilers might find it really difficult to diagnose. A profiler can tell you you're spending your time in this method and that method, that percentage of time here, that percentage of time there, but it's really not suited for this kind of responsiveness analysis, when and why this particular thread has stopped responding to user input. So this is what the timeline tool really is good for. And here's how it works. This isn't new. Visual Studio 2013 has this menu, Analyze, Start Diagnostic Tools Without Debugging. It's also called the Diagnostic Hub. It's like this one-stop shop for everything that's somehow remotely related to profiling, diagnostics, debugging in Visual Studio. It's all in one place. And this is that place. It's a screen that looks like that. Essentially, you tell this window what your analysis target is, in this case, my startup project, Stupid Notepad, and then it tells you which tools are available to do all kinds of diagnostics on this application. And in our case, it's going to be the timeline tool, which helps troubleshoot responsiveness issues. And I'm also going to go with the CPU usage tool, which tells me where I'm spending CPU time in this application. And you'll notice we can combine multiple tools, and this nice window tells me which tools are combinable and which are not. So once I pick timeline, I can't use the memory usage tool. But I can still pick CPU usage and GPU usage and the network tools as well. Most of these are not quite new, but really an adaptation of existing experiences in Visual Studio. But the timeline tool is really brand new. So I'm going to run the application under this new responsiveness tool. And you'll notice in the background, even though I haven't stopped the application yet, there is already this sort of dashboard showing right now CPU utilization, and there's a couple of additional things down there that I'll show you soon. So I'm going to start typing again. This is the responsiveness issue again. I type, and sometimes it just gets stuck, and it's not responding to my input fast enough. OK, there we go. Multiple long, annoying delays. OK, and then I close this thing. And Visual Studio says, stopping your diagnostic sessions. Now, please bear with me. This is an Azure virtual machine, which is running this Visual Studio preview. And so there's lots of potential points of failure. So I have a backup in case it doesn't work. But it seems to be working OK for now. There we go. OK, so let me begin by saying that it all looks pretty modern and nice, right? Like a modern dashboard and not these text-based old-fashioned tools. But it's actually useful as well. So what I have here is 3 graphs. One for the UI thread utilization, which tells me what my UI thread was doing. So to understand if I have a responsiveness issue, I have to monitor my UI thread. Then I have visual throughput, frames per second. How many frames per second am I able to render and display? And finally, I have CPU utilization, percentage of all processors, which is just a combined metric that tells me if I'm doing any CPU work here. So you can see during the time I was explaining things, nothing really was happening, no rendering, and also no significant work on the UI thread. But then once I started typing, about 22 seconds in, and let me just zoom in on that part. OK, I'm going to zoom in. So about 25 seconds in, there's lots of work on the UI thread, and the colors have meanings. As you can see here, green is application code, and you also have I/O, rendering, layout, and parsing. Parsing means XAML parsing, not parsing JSON documents. It means parsing the XAML, the XAML documents. So most of the time is really application code here. That's what my UI thread is doing. And you can also see pretty clearly that the frames per second which the UI thread is able to produce, the rate of frames per second is dropping pretty often. So we have this segment over here, and this segment over here, and this segment over here, and here, where we're actually producing 0 frames per second. And even when not, we're not always able to sustain 30 or 60 frames per second. There's these ugly drops over here. And so it's pretty obvious now that we have some kind of responsiveness issue and that our UI thread is responsible for it. So the UI thread is doing too much work. And that's why we're not being able to render the screen fast enough. But what is it doing? I mean, what is this application code? It tells me nothing. So the good thing is we also used the CPU usage tool in parallel with the timeline tool. And so I'm able to go and pick a region here which looks particularly bad. And then on the bottom over here, I get a CPU usage tree, which tells me where in my application I was spending CPU time during that particular selection. So I select a piece of my UI thread, of my UI thread's timeline, and then I get this tree, which tells me where I'm spending CPU time. Now, it is really a tree. So it starts with main, but let me expand this thing. And after expanding a couple of times, you can see that 69% of the total CPU time was in one method and its descendants. And the method is called main window text box key up. Now, key up is probably what happens when I lift my finger from the keyboard as I type into that text box in the main UI. And so that method over there is responsible for lots of CPU utilization. Now, this could be interesting enough on its own. We could go to that method and start looking at what calls it's making, how exactly is it spending so much CPU time. But I can also click this button over here, this link over here, called Create Detailed Report, which generates a traditional Visual Studio Profiler report file. So if you've ever used the Visual Studio Profiler before, it's going to look very familiar now. It's the same thing, but for that particular section which I've selected. So again, it's loading lots of stuff from disk and from the symbol server, so it could take a couple of seconds. And then we'll have a more detailed view coming up here, OK? So it tells me here, again, that this is my hot method, textbox key up. But the thing is, in this traditional profiler report, I get more detailed information than before if I click that particular method. And the extra level of detail is twofold. First, right over here, I can see which functions my function called. So my function is textbox key up. It calls these additional functions, which I can go to and now see what they were doing. Additionally, I get this really nice heat map in my source code. So if the profiler is able to resolve symbols and to resolve where my source code is, and I can actually tell it where to find the source code if it can't, then it will give me this nice heat map that says, well, 56.7% of your total CPU time was in this check spelling method and its descendants. Now, I think you realize by now that we have the UI thread spending lots of CPU time on spell checking, which is probably something you can do in a background thread just as well. So I'm not going to spend time on fixing, so to speak, this problem and then illustrating that the responsiveness issue is gone. I hope you believe me that it does. But anyway, the timeline tool, together with the CPU usage tool, which isn't new, is really useful for this sort of investigations. So that's one thing I wanted to show you in Visual Studio 2015. The other thing, if I can just get this to work, if I run this thing with just a plain F5, a debugger attached, and break, then I hope I'll be able to show you the new visual tree experience. So yeah, if I just break into the debugger, then on the left here, and on the right over there, you have two new windows. One is the Live Visual Tree Explorer, and the other is the Live Property Explorer. And so the idea is that here on the left, you have the structure of your visual tree. And so I can expand and expand until I get to a particular rectangle, which is part of the text box, which is part of my whole window. And then once I click something here, I, supposedly get this property explorer over there, which I can't get to work right now. But the idea is it will show you the properties this type has, the rectangle type that is, and you'll be able to edit them as well as to read them. I think in CDP 6 this might be fixed. I'm not sure. It's all kind of flaky right now, as you can see. But this is another thing which will be pretty cool for people building WPF desktop applications. It's all also going to be available for Windows Store apps, Windows Phone apps at some point, universal applications really, but probably not for Windows Forms, in case you've been wondering. OK, so that was the debugging experience around WPF. Let's move on. There's lots of additional cool things. So one thing I'd like to mention, which is relevant for C++ as well, again, in that same diagnostic experience, is a really nice feature, which is part of Visual Studio 2015, Visual C++ 2015, the compiler as well, and that's memory leak detection for native application, for unmanaged code. Now, even if you're not building a full native application, you might still have C++ somewhere under the covers. And chasing memory leaks in C++ code can be pretty bad. And there are some really, really, really expensive tools for sort of profiling memory leaks in C++ applications. There are also some free tools which are rather hard to use. So Microsoft in Visual Studio 2015 will give us a free tool for analyzing C++ memory leaks. So considering we only have a few C++ developers in the audience, I'm going to make this demo real short. But it's a great feature which will make many people really happy. So let me quickly show you this thing. It's a really simple MFC application written in C++. And it's leaking memory. If I just go to Task Manager and show you the memory usage for this application, battery meter, you can see here it's leaking about 1 megabyte per second, which is pretty quick. And it will run out of memory before the day ends, so I'm not going to let it. I'm going to run this thing, again, in Visual Studio with the memory usage tool for C++. And there used to be a similar thing for .NET, which is still there. But for C++, we didn't have a memory usage tool in Visual Studio. So that's brand new. If I run the application under this memory usage tool, then it might look, for the .NET developers in the audience, it might look exactly like your run-of-the-mill .NET memory profiler. It shows you your memory usage over time. And then there is a Take Snapshot button, which you can use to capture snapshots of your heap over time. So if you've ever used a .NET memory profiler like .memory, like Ant's memory profiler, a bunch of other tools, it looks exactly the same, except it's for C++. So for instance, if I hit Take Snapshot here, it takes a snapshot of the C++ heap and not the .NET heap. So C++ objects and not .NET objects. And I can capture multiple snapshots like this. And you can see my memory utilization is climbing. And then as I stop, I can compare these two snapshots and see which memory was added, which objects were added and not reclaimed. So again, if you've ever used the .NET memory profiler, it's going to be very similar. On the left, we have that much memory and that many objects. On the right, we have that much memory and that many objects, which is an increase of 6 megabytes between the two snapshots. And if I click this particular increase over here, then Visual Studio can show me which objects exactly have been allocated and not freed. So what are those objects that constitute this difference between the snapshots? So yeah, OK, it's stuck, but it's working on it, I think. I'm clicking real hard. I think you can hear me clicking, and clicking. Yeah, so it's not doing anything. Let's try view heap contents over here. Delightful. That's unfortunate. How about if I click something? No. Great. Yeah, so it just basically decided to stop working now. But in any case, what you can see here, even though it's not working, it's not fully functional, what you can see here is the individual allocations, so which objects and at which addresses these objects are. You can see the call stack, which made those allocations. So for example, this function over here was responsible for 29 megabytes of allocations total, and it called 2 other functions to perform these allocations themselves. And what you're supposed to see here, and I'm sorry for this not working, but I've warned you in advance, I'm supposed to be able to see the individual objects in a nice grid with their properties as well. So which objects exactly I have in the heap, including their properties. This, unfortunately, isn't working right now. So this is particularly interesting for C++ developers, like I've said, will be once it's working, really. But it's also interesting if you have a mixed mode application and you have a memory leak, and it's not a managed memory leak. So you don't need super expensive tools. You can try Visual Studio first. And it's a really valuable addition. So moving on to some other diagnostic features. This is the one thing in this presentation which isn't available in every edition of Visual Studio. But I really had to include it because it's a feature that's been completely redesigned and made much more useful than it used to be. And that's IntelliTrace. So have any of you ever used or heard of IntelliTrace before? OK. Oh, cool. So quite a few. It's not the usual response. Usually, I only have like one person in the audience who's ever heard of IntelliTrace, so this is really cool. So IntelliTrace, just in a nutshell, is a kind of a combination of a profiler, logger, and debugger, which runs in the background when you're debugging your application and collects information on what your application is doing. For example, file accesses, UI gestures like button clicks and menu interactions. In a web application, it can collect requests that are being processed, error pages that are being served, any kind of exception that happens. So it's just sort of a debugger aid that runs in the background and collects all this additional information. And the reason many of you aren't using it like 5 times a day or maybe 50 times a day is that it's only available in Visual Studio Ultimate, which is the most expensive edition of Visual Studio. And so, unfortunately, it hasn't gained the traction it really deserves. But in Visual Studio 2015, even though it's still only in that super expensive edition of Visual Studio, it has been made much more useful. And so let me just show you a quick demo. And as you see, I'm not trying to sell you on IntelliTrace. I realize it's an expensive proposition. And I just wish you could all apply pressure on Microsoft to make this available to more developers, because it is so useful. So let me show you a quick demo. So the buggy application we have now is a bit different from before. It's also a kind of notepad, but it has a different bug. And this one here is also a WPF desktop application, but it's absolutely 100% relevant for any kind of .NET app that you have. So I open a file, just a text file. It's got some, text. And then I scroll down, and there's this line over here which I don't like. And so I change it, and I hit save. And then as I hit save, the whole thing scrolls up, which is kind of annoying. And let me reproduce this. I just go over here, and I change it again, and I hit save, and it jumps up, it scrolls up. Really annoying. So what would you do to debug this? Like, if you had this thing in front of you? Anyone? If this was your code and this was your application, and it would just suddenly jump to the top when you hit save, what would you do? What was that?
Put a debug on the binding set or get of the property that's populating the text.
So you're saying at some point this text box is being populated, and you'd set a breakpoint or something to figure out where it's being. Yeah, but how do you figure out which action is repop?
Well, the save event is two-way binding.
The save.
Sending and then reloading.
OK. Maybe I'd start even with the simpler approach. Maybe put a breakpoint in the save method and see what it's doing. But we have the tools to debug this kind of issues, right? We have breakpoints. So I'm just going to give it a try just to show you that it's really not particularly good. So I have this save method somewhere over here. So this is open. And sorry, I should also have save. There it is. Button save file click. It's really ugly code. And oh, my. Yeah, Visual Studio finds it really difficult to go there. There we are. So this is the save method. And just, looking at the code, there isn't anything particularly suspicious here. What it says is, let's open a file writer and then take the text box contents and make it a byte array, and then write that to the file, and if anything goes wrong, show an exception message, which isn't happening, and then set focus on the text box. So does anyone think that the focus thing is responsible for what we're looking at? Yeah, could be. OK, so this is kind of psychic debugging, and occasionally it works, but usually it doesn't. So let me uncomment this focus thing and try to run this again. And you'll see it doesn't really change anything. So I open my text file, and I navigate down here, and I change it again, and it still jumps up when I save. So at this point, I mean, suppose we did put a breakpoint in here. There's no interesting code here. It just goes and saves out the text. There's nothing here which could suggest the text box is changing. So now, you've got a bunch of approaches like binary debugging. Let's remove this chunk of code and see if it still works, right? So this is a good example, I think, of where IntelliTrace can be useful. So watch. I just run this thing under a debugger with no breakpoints in mind. And I just reproduce. I open my text file, and I go over here, and I change it, and save. And I mean, the problem reproduces. And then let me just break into the debugger and show you something. So right over here, we have the diagnostic tools window, which you kind of already saw. I can run my application with the debugger attached and also see memory usage and CPU usage. And it's all showing in these tabs over here and the graphs over here. So here we have memory usage, and here we have CPU utilization. But that really has nothing to do with the issue we're looking at. The interesting part, which is the interesting thing is that it's integrated into this same experience, is that we also have this list of events down here. These are events recorded by the debugger as our application was being, debugged. And this comes from IntelliTrace. This is that super expensive feature of Visual Studio that I've mentioned, IntelliTrace. It's a collection engine that produces this additional information on stuff that's happening in the background. And so just to give you an idea, here's what it looks like. So at a particular time point, at 17.86 seconds since application start, we clicked the save button. Now, a typical debugger wouldn't make note of it, but IntelliTrace does. And so we have this record over here. You clicked save. And then pretty much immediately afterwards, same time point, same timestamp, the application is accessing a file and then closing it, and then accessing the file again and then closing it. And then we hit the debugger break, which isn't a breakpoint. I just hit the break button, so we stopped over there. If I go backwards in time, I have more of these events. For example, when I click open, when I click the open button, then it accesses the file and closes the file, but just once. And so when I hit save, it does it twice, and that's kind of suspicious, I think. And again, this information comes from IntelliTrace. It just runs in the background and records these interesting events. But it doesn't stop there. So suppose I want to look at those file accesses now. Click this guy over here. And then it says, initialize the file stream to the path c/temp/file.txt. Activate historical debugging. So if I click activate historical debugging, watch what happens. On the left-hand side, it shows me the point in my source code where I emitted this event, where the debugger caught that event when it happened. And so here's the particular point when it happened. It's our familiar save method. So whenever I hit save, then obviously this file open write call will open a file. Wow, really incredible surprise. And then I also close the file. So if I go to this close event over here and click activate historical debugging, then it tells me that at this closing brace, it closed the file. Surprising? Not really, right? I mean, here, open file, close the file. Awesome. But what about the second pair of events? So here's another file access to the same file. Let's click Activate Historical Debugging. And this is something else entirely. Somehow, we reached the read file method, which really wasn't part of our initial flow. So when you save a file, it somehow ends up calling read file. Now, I could now, with this additional knowledge, put a breakpoint in the read file method, run this whole thing again, and see how we got there. I mean, like, why is it calling read file when I save a file? But I don't have to do that. IntelliTrace also records the call stack. So we know how we got there. Why was read file called? Here's the call stack where the read file method came from. It's not right now. It's not our current call stack. So it says over here, call stack historical debugging. We're looking at a point in time which the historical debugger recorded. And now that we have that, I can see here open file calls read file. So I can double click open file and see that really if read file is being called, it's not a surprise that the text box is being cleared because we are assigning to its text property. And if I want to know what called this thing, then I just go further back on the call stack, and we see there's a method called here to a method called onFileChanged. And that suspiciously sounds like some kind of file system watcher, which is what it is. If I go just one frame further, then here we are. So let me just resize this thing a little. So this is obviously a method that's registered for a file watcher, a file system watcher. And if the file we currently have opened was changed, then we invoke back to the main thread and call onFileChanged, and that ends up reloading the file. So as we save the file changes, and then we reload the file. Now, I know it's kind of a contrived situation, but if this were to happen to you, you could spend a lot of time chasing this bug, because you really don't expect to look in the file saving changes thingies, especially if someone else was in charge of them. So this is one example of using IntelliTrace to sort of go back in time. You have a history of what your application was doing, and you can go back to any point in time, just click this link, activate historical debugging, and see what the application was doing at that moment. Now, why am I telling you about this if IntelliTrace isn't a new feature? Because this whole window, this whole thing is a complete redesign. They've re-implemented the whole UI pertaining to IntelliTrace. They're working on it, and there will be more features released in the final version of Visual Studio 2015, which aren't currently in the public previews. So IntelliTrace was initially released in 2010, in Visual Studio 2010, and then for 5 years, they kind of forgot about it a little, and now it's coming back to life. And again, hopefully at some point it also reaches the other editions of Visual Studio, the cheaper editions, and more developers will have the chance to become exposed to it. Because once you get used to it, you really can't go back, I have to admit. The preview, by the way, is the Ultimate Edition, so you can try out the preview anyway if you'd like. OK, so that was IntelliTrace and what happened on the IntelliTrace side of things. And that sort of concludes the debugging and diagnostic side of Visual Studio 2015. Let me talk about some additional features. One thing that changed is the NuGet gallery experience. And this is mostly a UI change, so I'm just putting it here for completeness, but it's something lots of people are really excited about. The NuGet dialog used to be modal, and it blocks your whole Visual Studio progress, and you kind of can't move back to your source and see what exactly you need, which packages you need, and so on. It's now a non-modal dialog, which you can open as a tab next to your other tabs in Visual Studio and navigate the various packages you need. It's also been re-implemented, again, from scratch. The UI itself was rewritten from scratch. I gotta say, I don't particularly like it, but it is more responsive, and non-model doesn't block you as much as it used to. Another cool feature, which is which was introduced, I think, in Visual Studio 2013, is Code Lens. Code Lens is these nice indicators that show, that appear on top of various code elements, like classes and methods and fields. And some of the things that Code Lens can tell you are how many references this method or class has, what was the most recent change to that piece of code, to that code element, how many changes in overall, what bugs does it have open against it, and even tests, passing and failing tests against that particular code element. And so in the V2 version of Code Lens, which is going to ship in Visual Studio 2015, there's going to be Git support. So if you're using Git for source control, you'll be able to see changes, commits, authorship against the various code elements, because currently it only supports TFS and not Git, but it will support Git, standalone or hosted in TFS, it doesn't matter. And there's also going to be this really nice activity dialog where you can click a code element and see who touched it most recently, but also a history of changes. So which developers touched that particular class in the last n days. So Code Lens is a really nice UI feature, and if you're using source control and collaboration and other collaboration tools, it's even more powerful. And if you're using other Microsoft tools from this ecosystem, like the Visual Studio Test Runner and source control integration, like I've said, then it all really shapes up a nice collaboration experience. So that's Code Lens. Not gonna show you a demo of this, but it's really something you should be using if you are invested into the Microsoft ecosystem. One thing I would like to show you a demo of, because I really like the way it matured from a research project to something that's going to be part of Visual Studio, is called Smart Unit Tests. And this is kind of the holy grail for people who have a large legacy code base with no tests at all. It's a starting point for writing hundreds of tedious unit tests. So if you have really complex, large, old projects with no unit tests at all, it might be interesting to give this thing a try at generating the initial shape of your unit tests for you. And this isn't particularly new. It's a research project, like I've said. It used to be called PEX. It was a Microsoft research project, later Microsoft Dev Labs. And finally, in Visual Studio 2015, it's going to be part of the final product. And so let me just show you what it looks like. I have here a project called Jack Compiler, which is a C# implementation of a compiler for a small toy language called Jack. So it's called Jack Compiler. Now, it's not a particularly big project, but it does have quite a few files and, of course, dependencies between them. There's a parser and the tokenizer, symbol table, code generator, the various parts of that a compiler has to have. And particularly, I have this tokenizer class over here, which is responsible for taking source code from a text reader and splitting it into tokens, the tokens this language should recognize. And there is not a single test. So let's try to generate tests automatically for this tokenizer guy. So I have smart unit tests on my menu now in 2015. And if I click this, it builds my project, and then it starts creating tests. This is the Smart Unit Tests window. It starts creating tests by kind of exploring my code. So it takes every method and tries to come up with inputs that would break it, essentially. In some cases, everything goes fine. In other cases, an exception is thrown or some boundary condition is hit, and then it tells me what exactly happened in that test. And this whole execution history, which I'll show you in detail right now, this whole execution history isn't lost when the run ends. You can take every single one of those rows and turn it into a standalone test. So let's take a look. For example, this guy over here. What was the test in that case? So what the smart unit test engine did was the following. It created a string reader based on only this string, the tab character, and then it created a tokenizer on top of that string reader, and then it advanced the tokenizer, advanced it to the next token. And then there's a bunch of assertions. The first assertion makes sure that we are on line 1 of the input. So the tokenizer current line property is 1. The second assertion says that the hasNext property of the tokenizer is false, because it has already consumed the only token that was in that input string. Now, this is a pretty clever test. I mean, I would probably need that kind of test in my test suite, where I create a tokenizer, give it 1 token, consume that token, and then verify the state of my tokenizer. Let's try another of these tests. So this guy over here, this is a different test, where the input string was just the capital letter T, and the test is not just for r equal int, the current line, and the hasNext properties, but there's also a test that the token type extracted by the tokenizer is token type identifier, because that's the only thing that works if the input string is a T, a capital T. Let's take a look at one of the failed tests. So this failed test over here failed as follows. The input string was G and then the null character. And that just fails and throws an exception. And what was the exception? You can see over here, the exception was compilation exception, and the error message was unexpected character, and there's probably supposed to be a null character over here, but it's not printable. So it's probably telling me that it didn't expect that null character. So again, is this reasonable behavior for my tokenizer? Is it not? I don't know. And the smart unit test engine doesn't either, but it generated this additional boundary condition for me. And there's dozens of those. Just look at this thing. It's already generated, and it's still running. It's already generated 30 interesting test cases which illustrate different boundary conditions for my tokenizer. Now, before I show you another couple of examples, I realize not every single piece of code you have is independent like this tokenizer over here. Because all you need to do to test this tokenizer is come up with a string and then start parsing it and testing it and stuff. And obviously, there are more complex classes which have a bunch of dependencies. The cool thing about smart unit tests is that you can give it mocks of particular pieces, and then it will generate test cases based on those mocks. So if there is a particular interface that you aren't going to use the real-life implementation of, you can give smart unit tests a mock, and then tell it, use that mock for all of the other tests you're going to create. And it will explore boundary conditions, but it will not do anything with that mock of yours. It's just going to inject that mock whenever a particular class is required. So it's a really powerful engine that's worth exploring more. Let me just show you a couple of more issues it finds. So this guy over here is an interesting exception. It's a compilation exception. Character ordinal is out of range 0 to 255. And what was the input? Let's see. OK, so it tried this input here, slash backtick, and then double slash, well, this is actually a single slash. It's in a string, 4 to 0. So apparently, this slash over here indicates to the tokenizer that we're expecting some kind of character formatted as a number, as an ASCII ordinal, and that fails because the number is too big. So again, is this an issue with the compiler? Should it throw an exception in this case? What kind of parsing should we use? I don't know, but it just found out another edge case. So if this number over here was 254, it wouldn't fail. But it figured that out, and it tried an input that does fail. I mean, I know it's 5 p.m., but it is pretty impressive. So that's smart unit tests. And once it's done, and obviously you can abort this whole thing, it's still running. It's still exploring. It's still generating test cases for you. Once it's done, you can just take this whole thing and create a unit test project out of it. So just a plain unit testing project in Visual Studio. And then you can start tweaking those tests to your liking. It generates a test project that runs and behaves exactly like this tests over here, but you can start tweaking from that point. And for certain kinds of code, it is going to be much, much easier than trying to come up with edge cases yourself. So it's something worth trying, especially for super robust, super reliable code that isn't allowed to fail. It's going to come up with every possible way to navigate through your internal code and make it fail. That's the beauty of it. So I'm just going to stop this thing. And once it's done, like I've said, I can tell it to save this whole thing to a unit test project. And I can also make changes if I'd like to rerun this thing. So that was smart. Ooh, sorry. That was smart unit tests, which is another feature coming up in Visual Studio 2015. And like I've said, it's really nice. It started as a research project, and it graduated into a full-fledged Visual Studio feature. So moving on, we're on the runtime side of things now. There's just a couple of interesting features left. And on the runtime kind of thing, side of things, the biggest change we're going to see in the .NET 2015 release wave, I think the biggest change, is a new just-in-time compiler. So if you remember the first slide of this whole talk, we had the 4 areas: Visual Studio, managed languages, the runtime innovation, and .NET Core going open source. So on the runtime innovation side, the new just-in-time compiler is definitely the biggest news of this release. And what it means, well, to implement a just-in-time compiler, it is a huge undertaking. It's a project Microsoft's been working on for at least the last 5 years, most of them in secret. I think about a year ago, they finally revealed their plans to replace the current just-in-time compiler with the next generation one called ReaJIT. And at this point, it's just a 64-bit just-in-time compiler. So for 32-bit, it's still using the old engine. But at some point, both the 32 and 64-bit backends will be replaced and unified. Now, there are 2 main reasons why Microsoft wanted a new just-in-time compiler, because again, it's a huge, huge project, roughly 220,000 lines of code, and not simple code, nasty compiler code that generates assembly instructions kind of code. So Microsoft went on with this project for 2 reasons. One is compiler throughput. The old just-in-time compiler, the one we're using today anyway, not so old, is really hideous at throughput occasionally. So there are some cases where it would take a very long time, a lot of time to generate code for a simple method. There are some pathological cases, but there are also some trivial cases where it just takes longer than reasonable. So the compiler throughput in ReaJIT is improved significantly. In the pathological cases, it's improved by a factor of 10, 20, and even more. In more reasonable cases, the throughput is improved by 20, 30, 40%. Now, this means good stuff for startup. It means your application will start faster. For example, one of their test cases is the Paint.NET application. It's a freeware photo editing tool, which is pure managed code, well, almost pure managed code, and it starts 20% faster under ReaJIT. Just switching the just-in-time compiler, it starts 20% faster. This is going to be very useful for client applications, but also interesting for server applications where if you have a restart, a recycle, whatever, your application will restart faster. There are also lots of improvements around regular expressions. These are the main cases where the old JIT used to be very slow. Native image generation for the whole .NET framework is now faster, and this is something that happens during .NET installation or Windows updates. So after a Windows update, it will be faster to start up .NET applications. It will be a quicker native generation process. There's lots of improvement around throughput, so the compiler just compiles faster. But I mean, the other aspect is just getting better code. So the compiler compiles faster, but if it's generating poorer quality code, it's not really worth the effort. So it's also higher quality code. ReaJIT, in most benchmark, already beats the old JIT considerably. There are some benchmarks from the mono runtime where it's actually a bit slower. The gray areas here is just statistical noise. So if you see anything falling in the gray areas, it's statistically insignificant, but there are some benchmarks where there is a 20 and 30 and 15% improvement. This is code quality, so the code runs faster. Not just the compiler runs faster, but the generated code is also faster. Now, Reagit currently is in preview. It's going to ship with Visual Studio 2015. It's going to ship with the next .NET framework, so it's coming very, very soon, which means Microsoft at least think it's pretty mature for production use. However, you will have a way of turning it off. So if you see any compatibility issues in production after upgrading to the next .NET framework, you will be able to use the old just-in-time compiler engine. I hope it doesn't happen to any of you, that you run into a compiler bug. It's particularly nasty because it's a just-in-time compiler bug, so it could, hypothetically, it could happen in production one day after the administrator installs an update, which is really, really nasty. So I hope you don't run into any issues. Microsoft has done some extensive customer testing with this, but I think you should know that there is going to be a potentially large breaking change if you are in one of those edge cases. So this is Reagit. And if you'd like to try it out right now, you can use it as part of the preview. So if you install Visual Studio 2015 preview, you get the new .NET framework, and you get Reagit for any .NET code you run. So this is a good way to see if it affects compatibility for you today. So I'm not going to show you a demo of Reagit. I have something slightly different to show you, which has to do kind of with Reagit, also on the runtime innovation side, and that's SIMD support. I'm not going to go into a lot of depth on SIMD, but basically, SIMD is a technology built into modern processors that can perform certain kinds of operations on multiple data elements at a time. For example, a traditional processor, the model we have of a traditional processor can add 2 integers at a time. So one instruction adds 2 integers. However, for the last 15 years or so, modern processors have instructions that can add 4 integers with 4 other integers in a single instruction. And even more modern processors can do 8 integers plus 8 integers in a single instruction. And not only a single instruction, but also a single processor cycle. So the same time to add more integers. Now, this requires, if you're trying to leverage this in your code, it used to require pretty much hand assembly coding. So you'd have to know which instructions to produce, and you'd have to either just hand roll your assembly code or use wrapper libraries that would take care of this for you. But nothing of this sort was available for C#, for .NET applications. And this changes with Reagit. The Reagit has intrinsics, sort of hidden paths in the compiler, which you can use from C# to emit these SIMD instructions at runtime, instructions that process more data in parallel. So I'm going to show you just a very quick example. And if this is interesting for you, say if you're doing image processing, if you're doing lots of algorithmic manipulation of data at runtime, if you have CPU-bound parts of your application that process lots and lots of data at once, this could be potentially interesting for you to explore. So let me just show you a quick demo. This is a simple application which is part of the SIMD samples. It's an open source sample you can find online on GitHub. And what it does is generate the Mandelbrot fractal and then zoom in on a particular part of it. It also keeps track of the elapsed time. So to reach the particular section which we were interested in, it took 9.6 seconds in the basic single-threaded version. Now, if we use SIMD, which is a different version of the algorithm, which uses these code paths in the JIT to generate the more sophisticated instructions, and run this demo again, you can immediately see it's a lot faster, and the elapsed time is just 3.2 seconds. So 9.6 versus 3.2. And this is a single thread. If you think I'm cheating here and using multiple cores and that's what I'm selling you, no. I'm not talking about multiple cores. I'm not talking about multiple threads. I'm talking about single-threaded performance, which has always been around, but you couldn't leverage it from C#, and now you can. If I add multi-threading, so if this thing runs on multiple cores, then we can get the time down to 0.8 seconds, which is another 4-fold speedup. So the whole thing together is from 9.6 seconds to 0.8, which is crazy. But again, the multi-threading here isn't the key part. The SIMD, the ability to use instructions that manipulate multiple data items at once, is the really incredible thing. If it sounds interesting, I encourage you to explore this sample. It's pretty easy. I also have a couple of blog posts on the SIMD support in Reagit. It requires the new just-in-time compiler, and it requires some additional code. It's not magic. It doesn't take your existing code and make it 4 times faster, but it does give you the tools to take particular sections of your algorithms and vectorize them to use these crazy new instructions. It's kind of like parallelism, really. There are no tools yet that just take your code and magically split it across multiple cores. So it's pretty much the same thing here. You have to work a little on specific loops, on specific sections of your application to make it possible for them to run using these new vector instructions. And by the way, I'm saying new vector instructions. The instructions aren't new. The .NET support is new. This whole thing is really not new if you've been doing C++ or Fortran or any native languages like that. It's been around for years. To do this from C# is really breaking news. OK, so that's the Reagit demo I wanted to show you, just kind of illustrating some of the things we can get from the new compiler. And the last thing I'd like to talk to you about today, which is also on the runtime innovation part, is a really incredible effort called .NET Native. Used to be called Project N. Have any of you heard about Project N or .NET Native before? Cool. So Project N was announced, I think, about a year ago, maybe a little less. And it was really unclear what exactly this thing is going to be. It was a code name. It was really cool. Everybody wanted Project N, but nobody really knew what it is. I think for about 6 months, it's pretty clear what the scope of the project is right now. But it's got a really bright future. So let me tell you about it a little. .NET Native produces a fully precompiled executable from a managed application that doesn't depend on the .NET framework at all, on any installation of the .NET framework on the production machine. So you can take your C# application, compile it down to a native exe, which doesn't depend on the .NET framework whatsoever. It doesn't mean it's not managed anymore. It still has garbage collection. It still has metadata. It still has the basic services. But it doesn't depend on the .NET framework anymore, and it's fully precompiled. So there is no just-in-time compilation. The whole thing is down to assembly, to machine language at compile time. Now, why is this interesting? First of all, it can really bring down startup times, because it means there is no just-in-time compilation. You start this thing, and it's all compiled already. There are potential gains in memory usage, because this whole compiled thing is really trimmed of fat. So there are no excessive parts that you don't need at runtime. Your final executable only contains what you really use in your code. You're not dragging in assemblies that you don't need. And 3, you don't depend on the .NET framework anymore. So you have this one exe which you deploy to the target system. You don't care which .NET framework is installed. You're not affected by any updates. You're not affected by any malicious system administrators. You just put your exe there, and it runs, always runs. So this is a really cool undertaking. And I think many of us would really like to use it today. The bad news is, at this point, it's only available for Windows Store applications. So Metro, Modern, you know what I'm talking about? Not any other kind of app. Not ASP.NET, not WCF, not console applications, not WinForms, not WPF, just Windows Store modern apps. The plan is, as far as I can tell, I don't work for Microsoft, the plan is to make it available to more kinds of applications later. For example, I think it's pretty clear that the next version of ASP.NET at some point will have support for .NET Native. I think it's pretty clear that console applications and Windows services will have support for .NET Native. I don't know about Windows Forms or WPF, but I really hope so. So right now, it's just Windows Store. But still, it's kind of incredible that this was even possible, to take a managed application and all its dependencies and package it down to a single exit. So let me tell you a little about how it works. The standard .NET compilation pipeline, as you know, takes C# code, compiles it down to IL, intermediate language, which isn't machine code. It's not executable. At runtime, there is a just-in-time compiler, which turns it into machine code, and that runs at runtime. The .NET Native compilation pipeline is considerably more complex. There's a bunch of tools involved in translating your original C# code to this final optimized exit. And here are the steps. First, there is the standard C# compilation step, C# to IL. Then there's a tool called ILC, which applies a bunch of different optimizations. For example, ILC looks at all your application dependencies, every single thing you use from the .NET framework, and it merges it into your code. So if you only use this one method from this one class in this one assembly, you don't need the whole assembly. You're not dragging the whole assembly with you. Only that particular method and its dependencies are brought into that final compilation product. It's called tree shaking. You basically take the tree and shake it until all the unnecessary dependencies fall out. So that's what ILC does, among other things. At this point, it's still IL. It's still intermediate language. It hasn't been compiled down to native code yet. And then there is a second pipeline, which takes this IL and massages it to finally produce, through multiple steps, and finally produces native code, which doesn't have any IL in it. And this all happens at compile time. So there is no just-in-time compiler at runtime. The native executable is produced at compile time. Another thing you can gain in the process is that you can make better optimizations. If you're compiling down to machine code at compile time and not at runtime, you can spend more time optimizing. You have more opportunities for optimization because you can spend more time on these optimizations. And so one of the crazy things about this pipeline is that at some point over here specifically, this nutcdriver.exe phase, Microsoft uses the C++ compiler optimizer, the C++ optimizer to be specific, to perform optimizations for .NET Native applications. So the really powerful compiler optimizer for C++ is used to make optimizations in this .NET Native pipeline. So the result of all this is faster code, which doesn't depend on the .NET framework, doesn't drag in any unnecessary dependencies at all, starts up faster, and has a smaller memory footprint, which are all good things. The only downside is that you have to pre-compile the whole thing in advance, which means you're tied to a particular architecture. So you can't build any CPU apps like that. It's either x86 or x64 or ARM64, which is coming up at some point. So you'll have multiple platform architectures of the same app if you're using .NET Native. But anyway, it looks like a really valuable proposition. It's currently available only for Windows Store, but hopefully it's going to be available for other platform types in the future. Let me just show you quickly the workflow if you're using .NET Native. It's really super simple. I'm not going to be able to show you any performance improvements, unfortunately, but at least the basic approach. So there it is. Just takes a really long time to compile. So anyway, this is a simple Windows Store application. And I have two build configurations here for release and release native. And the difference is, under release, if I build this whole thing, even if I rebuild, clean it up and build, it takes about, I don't know, 5 seconds to build, maybe a little more. It's a virtual machine. Come on. Yeah, there it is. So about 10 seconds to build, maybe. Under the release native configuration, I have this additional checkbox checked called compile with .NET Native toolchain. You can install this on top of Visual Studio 2013, which is what I have here, or you can also put it on or you can also use Visual Studio 2015, which has this built in. So we just have this additional checkbox over here, compiled with .NET Native toolchain. And then if I build, it's going to run for a while. It even says, please be patient, as this may take several minutes. This is a much longer pipeline. And so if you're used to rebuilding your whole solution, it takes 30 seconds. That's not going to happen here. So really, your workflow with .NET Native should be, once you have something ready for testing, you build it with the .NET Native toolchain, and then that's what you give your testers. That's what you run your nightly tests on. It's not something you're supposed to use routinely in development. You're not supposed to make every build use this whole expensive toolchain. It really takes a few minutes, so I'm not going to wait it through. OK, so that's .NET Native, and that's coming in this huge Visual Studio 2015 release wave. Wrapping this up, there are a bunch more features which I could have talked to you about that really range from C++ development in Visual Studio for cross-platform applications, all the way through HTML and JavaScript, the Android emulator, which Microsoft announced out of thin air, application insights and release management, so on the DevOps side, Git integration, which was considerably improved in Visual Studio 2015. It's a really big release, and there's something for everyone, I think. Again, you might be doing C++, you might be doing .NET development, you might be doing front-end web or back-end web or all of the above, and Visual Studio 2015 will have something new for you to explore. I'm not saying this is the best release ever or anything tacky like that, but it is a big release. There's lots of new features. And so if you are considering an upgrade, you should know what you're getting into, and there's lots of value there to explore. On the debugging side, on the diagnostic side, profiling performance tools, on the runtime side with the new just-in-time compiler and .NET Native runtime, there's lots and lots of new features. And again, there's a lot more we didn't talk about. And like I've said at the beginning of this talk, let me just, for 1 second, go back to that very first slide over here. We've got Visual Studio 2015 covered pretty much OK. Roslyn is something worth looking into if you're doing managed code. On the runtime innovation side, we've pretty much talked about the important announcements. But then on the managed languages side, there's a bunch of new features in C#6 and VB14, which we haven't covered here. And there's another talk later this week. And there is this whole open source .NET Core, what does it mean for me, which we haven't discussed here. And there's also another talk on that later this week. So there's more to explore in this huge release wave. Anyway, we have a few minutes for questions. So I'd be happy to take a couple. And then if you have any longer issues you'd like to talk about, please feel free to stay and approach me later. So do you have any general questions? Yes, please.
Do you have any of that SIMD code in C# that you could
Do I what? I'm sorry.
Do you have any SIMD code that's using the features you were talking about?
SIMD? Yeah. So what would you like to?
I'd just like to see what it looks like.
Sure, no problem. So let me show you this particular example with the Mandelbrot. I'm going to do it really briefly, of course. I even had it open. So basically, the fractal generation is this loop over here, which runs over the y's and the x's. And for each point, it figures out if it's in the fractal or not, in the Mandelbrot set or not. And then, again, this is the scalar version, no SIMD. This is the vector version. So it is slightly different, but aside from all of these initializations over here, There is still a loop that goes over y's and x's, but it uses vector of float instead of float. And the inner loop is slightly different because it doesn't just apply, it doesn't just sum or multiply things. It has a conditional in it, so there has to be some more convoluted code to take care of the conditional. In a simple case where you have, say, you're adding two arrays to a third array, this is the canonical example, it's a really trivial change. It's basically replacing types with vector types. In more complex algorithms, it can be a total rewrite and more code and more complexity. So it's not an easy one-liner, okay? Any other questions? Okay, so if you have anything else to discuss, then please feel free to come by and ask. I think there's some kind of drinks thingy sponsored by Amazon now, so if you know where it is, then feel free to go. Thank you very much for coming, and I hope you enjoy the rest of the conference. Thank you. 2015, for example, if you're doing front-end web development, then you might need another session, probably about the same length, just to cover all the new cool stuff there is for front-end web application development. But if you're doing .NET on the server side, if you're doing classic desktop applications, even if you're doing C++, there's something here for you in this talk. So just to put things into context, Visual Studio 2015 is part of the so-called .NET 2015 release wave. Now, there is really no such thing as .NET 2015. There isn't a version of the .NET framework called .NET 2015, but that's sort of the umbrella under which Microsoft have chosen to put this whole release wave. So under this release umbrella, we have Visual Studio 2015, which is, for the first time, powered by the new generation of C# and VB compilers, which is the Roslyn compiler platform. This is a huge undertaking on its own, but I'm not going to cover Roslyn in this talk. So we're going to focus on the Visual Studio IDE and all associated features like the debugger, the performance tools. We're not going to talk about the managed languages themselves. Now, I have a talk, I think tomorrow, about C# 6. Which will cover most of the innovation in the languages. There was, I think today, a talk about Roslyn by some other speaker, whose name I don't recall right now. And that covered the compiler platform side of things. So there really is more innovation around Visual Studio and the managed languages and compilers than what we're going to see here. Then we also have the runtime side of things, the runtime innovation, which I will cover briefly. And so there's stuff like a new just-in-time compiler, investments in vectorization for C# code, really cool stuff that has to do with performance and boosting really the kind of things you can do with .NET applications. And finally, there's also the open source .NET Core, which was announced in November. It's basically a subset of the .NET framework, which is in fact, already open sourced on GitHub, and some additional portions of the framework which will be released on GitHub in the future. So this is, again, a huge announcement in itself, and on Thursday, I think, I have a session covering .NET Core. So just to give you the context for today, it's mostly going to be Visual Studio itself, the IDE, performance tools, debugging tools, and the runtime innovation parts. So with that said, let's just briefly review a few features, and I'll show you demos of the ones I think are particularly interesting for both .NET and C++ developers. By the way, do I have any C++ developers in the audience? Not even one? OK, oh, great. Thank you. Yes, excellent. I also do C++ a lot, so it's always good to see some fellows. Yeah, we're going to see one feature which is C++ specific, so it's pretty cool. But the rest of it is going to be C# and .NET mostly. So one thing I'd like to mention is the editor. And the code editor in Visual Studio 2015 now relies on the Roslyn compiler platform again. And so without going too deep into what exactly it means and what the Roslyn platform enables us to do, the editor and the related functionality like refactorings and live code analysis and those red squigglies you see when you mistype something in Visual Studio, all of these things were basically redesigned and re-implemented from scratch. which hopefully means they're working better. And there's also some ideas which Microsoft and Visual Studio kind of borrowed from other productivity tools, like, for example, this light bulb over there, which I assume some of you know where it was borrowed from. So anyway, there is lots of investment in the editor, in refactorings, adding new refactorings and new code fixes, as they're called. And most of this thing can happen live without requiring a compilation cycle. So you basically type some code, and Visual Studio, the IDE, the compiler, parse it on the fly and suggest code fixes and refactorings, which is more powerful than the way it used to be before. And it's also, in most cases, faster. One nice thing we get out of this whole new IDE reimplementation is a really nice preview support, inline preview for refactorings and code fixes. So you don't have to go through this model dialog which previews the changes the refactoring is going to make to your code. Instead, you can just see this kind of nice inline window which gives you an immediate preview. So for example, here, to remove unnecessary usings. There is also support in the same spirit for more code analysis features, including more opportunities for people implementing code analysis packs. And there aren't many of those yet, but some people in the open source community, some Microsoft MVPs, are working on a wave of open source analysis tools for C#, for Visual Studio. And one example of those efforts is the Azure Cloud Code Analysis Pack, which is basically this thing you install, you add to your Visual Studio, kind of like a NuGet package, and it will try to look out for patterns of using Azure features incorrectly. Specifically, right now, it's focused on a certain set of client libraries for Azure, such as storage and cloud services and websites. Not every Azure library out there, but it will look out for common issues as you type in your Azure-related code and offer you suggestions, quick fixes, refactorings, which can improve lots of things. They can be bugs that it will fix for you. Could be cost issues, like using an API, which might end up costing more money than an alternative, which these tools can offer. So it's going to be easier to author code analysis experiences in Visual Studio, again, based on the same Roslyn platform. And it was, in fact, possible before. It's not like it's the first time there's static code analysis and code fixes in Visual Studio, but it was extremely complicated. And I'm saying this as someone who wrote quite a few of those static analysis rules back in the day. It's an undocumented and pretty much your own process. So Roslyn changes all that and really opens up the field for more open source code analysis tools. By the way, I haven't mentioned it, but Roslyn itself, this new compiler platform, and the compilers for C# and VB are also going open source. They are, in fact, at this point, already open source. They used to be on Codeplex, and then Microsoft realized all the cool kids are on GitHub, so now they're all on GitHub as well. The migration was just completed a couple of weeks ago. So again, on the code editor side, there's a bunch of cool new features, which you're going to discover on your own, I think, as you play with Visual Studio 2015 when it is released. And by the way, like I've said, there are multiple previews available. I'm going to be working with CTP 5 and CTP 6 during this session, which are the latest previews. And once this thing is out, I really encourage you to give it a try. So let's talk a little bit more about the debugging side of things. This is So hi, everyone. This is an amazing room. And I mean, it should be a concert here or something and not a session on Visual Studio 2015. But that's what you get. So I hope you're enjoying DevWeek. And I'm looking forward to seeing you here for the rest of the conference as well. I have some talks tomorrow and on Thursday. There's lots of new stuff in the Microsoft stack. And one of the major announcements this year is and will be Visual Studio 2015. Which is just barely out. It's not in release form yet. There have been multiple community previews. CTP 1, CTP 2, all the way up to CTP 6 are now available. But it's not out yet. So some of the features I'm going to be talking about might change before the whole thing is finally released. And also, if you see some demo glitches, then you know who to blame. I've done my best, but there are some things that are still not quite reliable. There are demos that occasionally work and occasionally don't. So with that said, let's hope for the best. My name is Sasha Goldshtein. I live in Israel. I work for an Israeli training and consulting company called Sela. And if you'd like to stay in touch, there's my blog and Twitter. If you have any questions, please feel free to approach and ask. I do a lot of things, including, of course, programming on the Microsoft stack. So this talk here is going to be about Visual Studio 2015. There are several perspectives from which you could approach this kind of talk. There are so many features that it's simply infeasible to cover everything in just an hour and a half, and also give you some demos, not just show you screenshots. So I'm not going to talk about every single new feature there is in Visual Studio.